Hi everyone, today we're going to be talking about 8.5, which is the mean absolute deviation, or also known as MAD. Just a couple of things. Let's go ahead and kind of dissect what this means here. The first word is mean, and you guys know this word very well. And to find the mean, you guys know that we add a bunch of values together in our data set, and then we end up dividing by the number of values. So obviously that will be happening, and actually this is going to be happening twice when we find the mean absolute deviation. We're going to find the mean first, and then we're going to use the mean to make a whole new data set, and then we're going to find the mean of that data set. So we find the mean twice for this. The second part is this word absolute. You guys might also know this as absolute value. Let's go ahead and briefly talk about what that means. We know that absolute value is always positive, and we know that absolute value is a number's distance from zero on a number line. From zero on a number line. Well, we're not actually going to be using a number line today. We're actually going to be finding a number's distance from the mean. We still want to make sure that it's always positive. So you're going to see when I actually go and subtract, I'm going to make sure that I'm always subtracting a smaller number from a larger number so that we always get a positive value in our data set. So this might be a little confusing to you. Let's go ahead and write down some steps that are involved, and then we'll go ahead and practice this with a couple of problems. Here we go. So the very first thing you want to do is you want to order your data from least to greatest. Okay. This is just easiest to make sure you have all of your data values. You're going to see sometimes it's a little bit easier to add them together when they're from least to greatest, to combine those numbers together so you're not just writing one long addition problem. The second step is we're going to be finding the mean of our data. We already know how to find the mean. You're going to add all your data sets together and then divide by however many data values are given. The third step is you're going to find the difference. So we're going to actually subtract each number from our mean. Okay? And some of you might be scratching your head right now going, what? What does that even mean? I promise you we will practice this in just a second. It'll make a lot more sense. And then the last step is to find the mean of that new set of values. So as I mentioned, you're going to be finding the mean twice. Also be mindful that when you find the mean of a set of numbers, it is not always possible that it comes out all nice and pretty in a whole number. We might be dealing with some decimals today, and that's okay. Let's go ahead and practice this. Now, on the next slide, you're going to see a table. Please do not feel like you have to draw this table. This is just to help me kind of organize my data. You are more than welcome to just work this out naturally on your paper. Okay, so here we go. This is my set of data values. Don't be freaked out by these parentheses. This is my actual data set here. So what we're going to do first is I'm going to order these numbers from least to greatest. So I see I have a 4, and I'm going to cross it off just like I did before. I have a 5. I have a 12, a 19, a 23, and a 33. As you guys can see, this table isn't necessary. You can list these out on your own. There's no problem with that. Okay, now that was step 1, putting them in order from least to greatest. Step 2 is we're going to find the mean. So I'm going to add all of these numbers together, okay? So I'm not going to actually sit here and add them all together. When I do add them together, you should get 96. So when I add all these together, I get 96. Now, I'm going to be finding the mean right now. So I have to divide by however many numbers there are. And there are 1, 2, 3, 4, 5, 6. There are 6 numbers here. So I'm going to go ahead and divide to find the mean. So 6 goes into 9 one time. I'm going to subtract. I get 3. Bring down the 6. 6 goes into 36 6 whole times. And I finally get a remainder of 0. So My mean is 16. Okay, so we've done steps 1 and 2. Step 3, this is where things get a little different. I am going to take my mean and I'm going to take each number in my data set, and I'm going to find the difference. So I'm going to subtract. So I want to know, what is 16 minus 4? And that's 12. So I'm creating a whole new data set. So 16 minus 4. I want to know the difference between these two numbers. As you can see, I always want my value to be positive. So I'm subtracting the 16 from the 4, I'm subtracting the 4 from the 16, not 16 from 4. Okay, the next one, 16 minus 5. See how I'm going down each number. So 16 minus 5 is 11. That's another new number. 16 minus 12 is 4. You can't do 16 minus 19. 19 is too big, so we have to do 19 minus 16 to get 3. You always want them to be positive values. 23 minus 16 is 7. And then 33 minus 16 is 17. Now, don't be freaked out that these are not in order from least to greatest. That's not a problem. All we're doing for this final step is we're going to find the mean now of this new data set. So as you can see, these are 6 totally new numbers from my original set. Okay, so what I'm going to do is I'm going to add all these numbers together. When you add them all together, you should get 54. And we're going to find the mean of this set of data. So 54 divided by, there are still 6 numbers. So I'm going to divide by 6. And we don't have to do long division for this. 54 divided by 6 is 9. So my mean absolute deviation is 9. So like I said, quite a few steps involved, however, not super difficult. All things you've done before. You start by finding the mean. You subtract each number to get a new data set, and then you find the mean of that data set. Let's go ahead and try another one. Okay, for this one, we're going to start by putting these numbers in order from least to greatest. So I see I have 1, 3, I'm going to cross it off, 1, 3, 7, 15, 16, and 22, and 41. 41. All right, now that they're in order from least to greatest, let's go ahead and find the mean. So what I want to do first is I want to add all these numbers together. When you add these numbers together, making sure that you added them correctly, you should get 105. We're going to divide by however many numbers there are. So there are 1, 2, 3, 4, 5, 6, 7. So we're going to divide by 7. Let's go ahead. 7 can't fit into 1, but it can fit into 10 one time. 7 times 1 is 7. 10 minus 7 is 3. Bring down the 5. 7 goes into 35, 5 whole times. And 5 times 7 is 35. All right, so my original mean is 15. Okay, this is that next step where we're creating a new data set. So what I'm going to do is I'm going to subtract each one of these numbers from 15. So 15 minus 1 is 14. Does everyone see how I got my new number? 15 minus 3 is 12. 15 minus 7 is 8. I'm just going step by step. Don't let this freak you out. 15 minus 15 is 0. That's okay. 16 minus 15. Remember, you can't do 15 minus 16 or you're going to get -1, and we don't want any negative numbers in our data set. So 16 minus 15 is 1. 22 minus 15 is 7. And 41 minus 15 is 26. Okay, now that I have my new data set in green, we're going to find the mean of that. That's our final answer, our mean absolute deviation. So let's go ahead and add all these together. When you add them all together, you're going to get 68. We are still dividing by 7 since there are still 7 numbers. So here we go. 7 can't go into 6. It's too small, but 7 can go into 68 9 times. 9 times 7 is 63. And we get a remainder of 5. From here, please don't forget to add a decimal point and a 0 and bring it down. This is just basic long division. 7 goes into 50 7 times. 7 times 7 is 49. When you subtract, 50 minus 49 is 1. Add one more 0 and bring it down. 7 goes into 10 one whole time. 1 times 7 is 7. So when I subtract, I get 3. As I can see, I'm still going to continue to get remainders. So I'm going to stop and just make this my final answer for my mean absolute deviation. I normally tell my students to go at least 2 decimal places or 2 place values. So your final answer is 9 71/100 as your final answer. Okay, let's go ahead and do this last one. At this point in time, you are welcome to pause the video if you want to try this on your own and then fast forward to the end and see if you get the same answer as me. That would be great. If you still want extra guided practice, you are welcome to follow along with me. Okay, so let's go ahead. We have, putting these in order from least to greatest, 2, 5, 6, 14, 16, 20, and 21. Okay, first thing I'm going to do is I'm going to add these all together. So when I add them all together, I get 84. And I'm going to divide by however many numbers. 1, 2, 3, 4, 5, 6, 7. I'm going to divide by 7. 7 goes into 8 one time. When I subtract, I get 1. Bring down the 4. 7 goes into 14 2 times. 2 times 7 is 14. So I get a remainder of 0. So my mean is 12. Okay, this is where I create my new data set. So I have to subtract. I have to find the difference from each of these numbers. So 12 minus 2 is 10. 12 minus 5 is 7. 12 minus 6 is 6. This is where you have to flip it so it's not negative. 14 minus 12 is 2. 16 minus 12 is 4. 20 minus 12 is 8. And 21 minus 12 is 9. Very last step, my new blue numbers, my new blue data set, we're going to add those together, which gives me 46. And I'm going to still divide by 7 because there are still 7 numbers there. 7 can't go into 4, but it can go into 46 6 times. 6 times 7 is 42. You get 4 as your remainder. Don't forget to add a decimal and a 0. Bring it down. 7 goes into 40 5 times. 5 times 7 is 35. 40 minus 35 is 5. Add one more 0 and bring it down. 7 goes into 50 7 times. 7 times 7 is 49. So you still get a remainder of 1. So my decimal is going to continue going. Remember, I told my students to only go to 2 place values. So your mean absolute deviation is 6 57/100.